will say transverse and longitudinal wave. Now let's proceed. For longitudinal now, under longitudinal it says it is simply a type of wave in which the direction of travel and the direction of vibration are in the same direction. You can see it's very straightforward. The direction of travel and the direction of vibration, they are in the same direction. That is, let's say the wave is traveling towards this side. Here is the vibration. You understand? Direction of vibration now. This is the direction of vibration. This is the direction of movement or travel. So if the direction of vibration and the direction of travel are on the same plane, you understand? We name the whole wave movement as what? Longitudinal. Longitudinal. Hope you are getting it. So when the direction of the wave and the direction of vibration is on the same direction, we say that that particular phenomenon is called longitudinal wave. But for your transverse wave, how do you do that? Or what do you mean by that? It is simply a type of wave in which the direction of travel and the direction of vibration are perpendicular to each other. That is, the travel is towards this way, the vibration is towards this way. This is the travel direction. Vibration is in this direction. Are you getting it? So from there, they are almost at 90 degrees to each other. So meaning that direction of travel is perpendicular to what? Direction of vibration. So hope you are getting it. That analogy alone, as I explained, your transverse wave and your what? Longitudinal wave. So let's go to general representation of wave. Now at this junction we'll be looking at the graphical representation of wave, the major parameter that could be seen in every wave movement. The transverse wave can be represented with series of crest and shock. Okay, look at it. You have something like this. Now we have the starting point here. It goes up, down, up, down, up, down. Now the vibration, is turning up and down. Now the direction is this way. So definitely this type of wave is called transverse. Why? Because the direction of movement of the wave and the direction of the vibration is what? Perpendicular to each other. So at this junction now, we now say the highest movement, you understand, of the flow is what we call your amplitude. Now this is the region we call the crest, while the lower region is what we call the trough. The ability for you to complete one oscillation, that is from here, this is an half circle. This is another half circle. If you put it here, it becomes one complete circle. So for you to complete one complete circle here now, this is what we call your lambda. It's called lambda. Now, from here, we now have there's another one that you need to know. You have the period S. Measure the seconds. Now, the period is the time for you to complete one circle. The time for you to move from here to here. If you move from here to here, that's an half time. So if you shift this here, one complete circle. So the time for you to complete a complete circle is called your period. So it's just a graph that is very, very well understandable. Now in contrast, a longitudinal is made up of series of compression and refraction. If we plot the graph whereby y represents compression and x represents distance traveled by the what? By the wave. So meaning that there are also graphs for your what? Longitudinal. But we won't go to that. Let's look at the terms used. Terms used in describing a wave and the relationship between them. We have what we call our amplitude. As a wave progresses, the particles of a medium vibrate about a mean position. Now, the maximum displacement of a particle from their mean or rest position is called amplitude. That's the maximum displacement. Is what we call the amplitude. Now, your period T. It is the time required. I was saying it the other time, for a particle to perform one complete circle is what we call your period. Are you getting it? Now, why the frequency is the number of circles that is being obtained. Then we also have the wavelength. The distance along the x-axis between the successive trough. Do you understand? Between two successive troughs is called wavelength. It's the distance covered by the wave after one complete circle. Now, we're looking at another one we call the wave speed. Wave speed is the distance which a wave travels in 1 second. Do you understand? The distance which a wave travels in 1 second is what we call wave speed. Now, a relationship between period frequency, lambda, and what? Velocity, and that's the speed. That's what we are looking at now. Okay, let's go. We said frequency is inverse of what? Period. That's t. Velocity is the product of frequency times what? Lambda. Are we seeing it now? So these two formulas will be used in our subsequent calculations. Now let's check these exercises. Now under the first one, it said a wave travels a distance of 8 meters in 4 seconds. The distance between the successful crest of the wave is 50 meters. Calculate the frequency of the wave. Very easy. Very, very easy. How do you get the frequency? We already have the value for lambda. Are you seeing it? That's the distance, because we said our lambda, that's the wavelength. It's distance between the x-axis between two successful trough. Shall you understand? Or successful crest. So if the lambda is 50 meters, and your distance, that's your s, is what? 80 meters. We are given our period t as 4 seconds. We are told to calculate the frequency of the wave. So for you to get frequency is just 1 over period. That's 1 over 4. So by the time you divide, you're going to have 0.25 s. This will be my frequency. So that is just the value of the frequency that will be obtained. So without wasting much of our time, we'll go to equation of a traveling wave. Let's start with this traveling wave. If we have, you'll be very careful. Are you seeing them? So with this analysis now, we'll be able to understand that this particular wave, this particular one is y, which equals to your what? Cos theta. While the next one is your what? Your y, which equals to your sin theta. How do you get your cos theta? Cos theta is actually being obtained. You know, you look at the direction at which it started from. You know, by the time you plot out a triangle, then you discover that its resolution in terms of there's this thing we used to do in school. Look at, we draw a circle here, bring this here, bring this here. So this particular one, you understand? So you have something like this, you have something like this, you have something like this, you have something like this. So this particular angle, let's say this is angle 60 degrees, or let's say angle theta. Are we seeing it? So if you are to resolve this, you understand? This is hypotenuse. You are resolving it to this side, so it is the adjacent side. Are we seeing it? So if you resolve this down, is the adjacent side. So this is hypotenuse. This is adjacent. This is hypotenuse. So resolving hypotenuse and adjacent, you have your cos. Are we seeing it? Now for your sine, mind you, this one does not stop here. It goes down. Probably something here. You now have something like this. You understand? So by the time you have something like this, you now have something of this nature. Now, mind you, this is the opposite side. Shall you get? So this is the adjacent now. This is the opposite. So by the time you resolve opposite, which is to this angle theta, you'll be able to obtain your sine. So with that, you will be able to prove. Don't worry about this. Don't feel like this is an advanced level. By the time you get to a course you do while you're in school, if you have been admitted in engineering, there's what we call electrical electronics or electronics theory or electronic theory. You will definitely do that course and you'll be able to break down this particular topic confidently, and you won't have any issue. So don't focus your brain on this. You will soon get to see it later. Now from here, we have a complete movement of wave, and that's this. We have this is half pi. Now by the time it moves 1, 2, so the first one, the second one will give you 2 pi. That way, so you know this is half of a circle. That's why it's pi. So when the circle completes, it becomes 2 pi. When it goes like this, 2 becomes 3 pi. And when it comes, it becomes 4 pi. That way, you label it that way continuously. So how do we now bring wave equation into this? Let's go. We now say that both sine and cosine angle are periodic functions with amplitude which equals to 1 and period equals to what? 2 pi radians. Now, the general equation of what? Your wave is your y, which equals your amplitude sine sine your omega t minus phi. This is the general equation. So it's from this equation you will now be breaking a lot of things down. Number one, your phi, which is known as your angular distance, constant angular distance, is given as 2 pi x over lambda. That's your pi. Are you getting it? So from here, if we are to substitute, you have that, then your omega is given as 2 pi over t. The omega here, this pi here is given. So by the time you chunk up the whole, these two values into this equation, you have your y to equals to a sine into bracket. Oh yeah, you have your 2 pi over t, then your small t minus 2 pi x all over lambda. Are we getting it? So from there, you know we are getting another equation. From there, you now collect like terms of your 2 pi. So if you bring out your 2 pi, you'll be able to have something like this. Y equals a sine 2 pi into bracket t over small t. I mean, small t over capital T minus what? X over lambda. This is another equation. Do you understand? So we'll stop here, and that will be the actual equation of wave. Now from there, we'll now proceed to progressive and stationary wave. Now all waves, both transverse and longitudinal, which spreads out continuously, are called progressive wave. But a stationary wave is obtained when two progressive waves of equal magnitude and frequency are traveling in opposite direction. You get it? And combined together. Whether it's longitudinal, whether it's transverse, it is what? Progressive. Are you getting it? It's a progressive wave. But when two progressive collide, another one is coming towards this direction, and they collide, they now form something like this. They now form what we call stationary. This is what we call stationary wave.